speed and velocity. All right, so first problem deals with, we did similar problem like this already, right? So light from the sun reaches the earth in 8.3 minutes. So this here is our time. Okay, our time is 8.3 minutes. So I usually write down everything that's given to us. The speed of light happens to be 3 times 10 to the 8th meters per second. So this is our v. How far? So they're looking for the distance, d, right? Now it looks like this is meters per second and this is in minutes. So it's not going to really work out too well if we were to have this mixed units. So most likely we should change this into seconds, okay? So to do that, what we need to do is we can multiply 8.3 minutes. So in 1 minute, there are 60 seconds. And if you do that correctly, you'll get something like 498 seconds is equal to 8.3 minutes. So speed v is equal to, right, distance divided by time. Right? So if we were to redistribute the time by multiplying it to both sides, our distance then it is equal to speed times time. All right. So our speed, which happens to be 3.0 times 10 to the 8th meters per second, times time, which is 498 seconds. Okay, notice how the seconds will cancel out nicely. Right. And then we have our answer, the distance between the sun and the earth, which we already know it to be 1 AU, right, is 1.494 times 10 to the 11th meters. So that's pretty far out. Okay. Any questions on that? Good. Let's take a look at number 2. What must be you, average speed? I don't know, this is kind of really weird grammar, so I should put a comma here. What must be you, average speed? No, I fixed it, right? It sounds like Monty Python Holy Grail. Stand aside, worthy adversary. The victory is mine, right? Or if you want to change this, you could say, what must be your average speed be in order to travel 230 kilometers in 3.25 hours? So this is pretty straightforward, right? So I want to know what v has to be, right? So this here is the distance, basically, and this here is time, and we're looking for v. Come on, that's pretty easy, right? So our average speed then is equal to 230 kilometers. Divide that by 3.25 hours, and our average speed comes out to 70.8 kilometers per hour. Yeah, comma makes a lot of difference. All right, any questions on that? That was easy, except for interpreting the question. Those grammars messed up. All right, number 3. If you are driving 110 kilometers per hour, that's about like 65 miles per hour, right? That's the speed. Along a straight road, and you look to the side for 2 seconds. This is the time. How far do you travel during this inattentive period? All right. So if you look away to the side for 2 seconds, not keeping your eyes on the road, you'll be traveling a pretty much long distance. All right. That's only for 2 seconds. So here, the V given to us happens to be 110 kilometers per hour. Again, it looks like we have mixed units of time. So we should change, one to the other. I'm thinking maybe converting this into kilometers per hour into meters per second, so we can just multiply by seconds to get our distance in meters. So here, in 1 hour, there are 3,600 seconds, and in 1 kilometer, there are 1,000 meters, right? So if you work this out, our speed comes out to 30.56 meters per second as our average speed. Well, since we know speed is equal to distance divided by time, we're looking for distance. We know V, this is V, right? And we know T, right? We're looking for distance. So our distance then is equal to V times T, which is 30.56 meters per second times 2 seconds. So notice how the seconds will cancel out nicely, giving us 61.1 meters. That's about 2/3 of a football field you'll be traveling within that 2 seconds. All right. A lot of things can happen within that distance. So don't text and drive. All right. Let's take a look at page 9. Now, page 9 you have to read this very carefully. So what's going on with page 9? You are driving home from school steadily at 65 miles per hour for 130 miles. Okay, I guess you're living out of district. Huh? Well, this is actually a college textbook, so they expect you to drive from your college to your home. So this is about a Penn State distance, I guess, right? So just keep that in mind when you're reading some of these questions. So you are driving home from school steadily at 65 miles per hour for 130 miles. Then it begins to rain and you slow down to 55 miles per hour. Smart. You arrive home after driving 3 hours and 20 minutes. Right? So how far is your hometown from school? And B, what was your average speed? So there are 2 parts to this trip, right? So first part was when you were driving at 65 miles per hour for 130 miles. So from your school, you're driving home, right? So the speed in the first part of the trip happens to be 65 miles per hour. And the distance that you travel for the first part of the trip, D1, is 130 miles. We don't know how much time it takes. But we could probably figure it out, right? Then it starts to rain, so you slow down and you drive second part of the trip at 55 miles per hour. We don't know how much distance you drove, but we do know, right, the total time it takes to go for the whole thing. So the total time that it took you to drive was 3 hours and 20 minutes. That's not 3.2 hours. Matter of fact, that is 3 1/3 hours. Okay? Which is like 3.333 hours. Okay? We also know that T total is equal to, right, T1 plus T2. Okay? So maybe we could solve for T1. And once we find T1, maybe we can find T2 because we know T total and T1, so we could definitely find T2. So maybe we should find T1 first. All right? So here, my V1 is equal to D1 over T1. Therefore, T1 is equal to D1 over V1. And that is equal to 130 miles. Divide that by 65 miles per hour. Notice how the miles will cancel out, putting the hours on top. Okay? And that is equal to 2 hours. So once we know that, we can say T2 now is equal to, right, T total minus T1, right? Therefore, T total, which is 3.33 hours minus 2 hours, it's going to be 1.33 hours. All right? So 3.333 hours minus 2 hours is equal to 1.333 hours. So now that we know that, we can use this here to figure out the distance traveled. All right. So now we say V2 is equal to D2 over T2. So if we were to solve for D2, now we can say D2 is equal to V2 times T2. Therefore, right, 55 miles per hour times T2, which is 1.333 hours, right? Notice how the hours will cancel out. And it will give you 73.3 miles. So that's my D2, right? So how far is your, so we're looking for D total. So D total is equal to, right, D1 plus D2. And that comes out to 130 miles plus 73.3 miles. And our total distance comes out to 203.3 miles as the total distance. So that's part A. Now, for part B, they want to know what your average speed is. So your average speed, V, for the total trip is equal to, right, D total divided by T total. And that is equal to 203.3 miles. Divide that by T total, which is 3.333 hours. And your average speed for the total trip comes out to 61 miles per hour as your average speed for the total trip. Now, popular wrong answer would be, well, there are two speeds here, so if I add them up and then divide by 2, I should get 60. That's not correct because, first of all, the time is different and the distance traveled is different. If they travel same distance and same amount of time, yeah, and I guess you could probably do it that way, but you can't. Therefore, you have to stay with the definition of average speed, which is the total distance divided by total time. And total distance we calculated to be 203.3 miles. And the total time, 3.333 hours. Therefore, 61 miles per hour is the average speed. All right, so that's part B. Any questions? All right. All right. Moving right along. An airplane travels 210 kilometers at speed of 800 kilometers per hour. And then it encounters a tailwind. A tailwind is basically wind that's pushing the airplane from the tail side forward. So it's actually helping the airplane go faster. Headwind is when airplane faces wind coming towards the head of the airplane, and it's going to slow the airplane down. All right. So make sure you know the difference. So when it encounters the tailwind, that boosts its speed to 1,000 kilometers per hour for the next 1,800 kilometers. So we have two different trips here happening for the total trip, right? The first part of the trip, airplane is flying, let's say, 2,100 kilometers. So the D1 is 2,100 kilometers. At speed of V1, so this is the first part of the trip, of 800 kilometers per hour. Then the second part of the trip, it encounters the tailwind, right? So D2, it only travels 1,800 kilometers, and speed becomes 1,000 kilometers per hour. Okay? So what's the total time for the trip? Well, we should figure out the T1 and T2. Right? So we could probably do that by simply saying, okay, V1 is equal to D1 over T1. So if we manipulate this equation, my T1 is equal to D1 over V1. And that is 2,100 kilometers divided by 800 kilometers per hour. So notice how the kilometers will cancel out nicely. And that is equal to 2.625 hours for my T1. Then for my T2, my V2 is equal to D2 over T2. Therefore, T2 is equal to D2 over V2. And that is 1,800 kilometers. Divide that by 1,000 kilometers per hour. Again, the kilometers will cancel out, giving you hours at the top. And this gives you 1.8 hours for my T2. So, T total, right, is equal to T1 plus T2, right? So my T total is equal to 2.625 hours plus 1.8 hours. Therefore, that comes out to 4.425 hours. So slightly less than 4.5 hours for the whole trip. Okay, so that's part A. For part B, they want us to know what's the average speed. Well, average speed for the whole trip is D total divided by T total, right? It's that simple. So total distance traveled is this plus that, which is 3,900 kilometers. Divide that by T total, which is 4.425 hours. And if you work it out, you'll get 881.4 kilometers per hour. Booyah. Done. All right. Any questions? All righty then. Let's take a look at page 10. Here, we have a car starts at town D. Okay, so I will do problem 6 in aquamarine blue. So it starts at town D. So this is our initial starting point for my problem 6, and that's at positive 70 kilometers from the origin. And drives to town A, arriving 1.5 hours later. So this is my T, right? And this is negative 70 right here. And that's my final position. Okay. So, A, calculate the average speed of the car. Well, the average speed is equal to total distance, right, divided by total time. This is the total time. Therefore, the distance I travel from here to here is just 140 kilometers. And notice I don't put any negative signs or anything like that. It's just total distance. Divide that by total time, which is 1.5 hours. Therefore, when you do this, you'll get 93.3 WMMR, Philadelphia radio station. Now, so 93.3 kilometers per hour as your average speed. Okay. However, so this is part A, but for average velocity, our average velocity has this little vector drawn at the top, right? And that, by definition, is change in position over t total, okay? Well, t total is basically delta t, right? Which is t final minus the t initial, where initial t is 0, right? So my t final is t total, okay? So here, my change in position is basically x final minus the x initial over t total. That is, final position is negative 70 kilometers minus 70 kilometers x hat. Divide that by t total, which is 1.5 hours. So this becomes negative 140 kilometers x hat over 1.5 hours. So my v, average velocity, becomes negative 93.3 kilometers per hour x hat. Okay, I hope you can see the difference. Now, for number 7, I will do it in pink. So the car starts at town D again. So it starts at here. This is the initial. And drives to town A, arriving 1.5 hours. Just like before, it drives all the way to here in 1.5 hours. And then continues on to town C. So here is where we end up. And this is our final destination. So time here is 1.5 hours. And time here is 1 hour. So time total is equal to 2.5 hours. Okay? So for part A, let's calculate the average speed. So average speed V is equal to total distance divided by total time. The total distance traveled is from here to here is 140. Then it travels 100 more, so 240 kilometers is how much total distance it has traveled. Divide that by total time, which is 2.5 hours. So our total distance divided by total time comes out to 96 kilometers per hour as my average speed. However, for average velocity, we're looking for the change in position over t total. Therefore, position final minus the position initial divided by t total is what we're looking for. Final position is at 30. Okay? So 30 meters minus the initial position is 70. I should say kilometers. X hat Divide that by the total time of 2.5 hours. That is negative 40 kilometers x hat over 2.5 hours, and that comes out to negative 16 kilometers per hour x hat as my average velocity. So average velocity is equal to negative 16 kilometers per hour x hat. Notice the difference. Okay, are we okay with that?